In this session, let us see one beautiful question. Of course, it is random doubts. Okay, so this is also old gate question only. But I thought harmonics, detailed analysis of harmonics cannot be done because gate exam is nearby. Okay, but I will tell you how to solve the problem. Okay, now a 3-phase 50Hz square wave 6-step VSI feeds 3-phase 4-pole induction motor. The VSI line voltage has dominant fifth harmonic component. If the operating slip of the motor with respect to fundamental component of voltage is 4%, the slip of the motor with respect to fifth harmonic component of voltage is. Okay, so here we have to discuss many things. Okay, the first point is induction motor. Induction motor rotor will interact with all the harmonic components because, for example, rotor is rotating at maybe 950 rpm. Stator mmf is rotating with 1000. Okay, so stator mmf is rotating with 1000 and it is rotating with 950. So because of 50 rpm relative velocity, induced voltages, currents and torque will be there or not? Yes. For example, seventh harmonic component is rotating in the same direction with 7 times synchronous speed or synchronous speed by 7, both will be there. Okay, so because of that, rotor will rotate at 950 only. For example, my stator mmf 7th harmonic is rotating in the same direction with 7000 rpm. So 7000 rpm and rotor is rotating in 950, then also relative velocity will be there. Because of that, induced voltage will be there, currents will be there, torque will be produced. So underlying conclusion is very simple. In our previous sessions also, if you get any doubt, start from the induction motor starting analysis, you will come to know. So my rotor of my induction motor will interact and will develop torques with all harmonic components. Okay, now in your books say that fifth harmonic component ns by 5, seventh harmonic component ns by 7. No. Okay, basically there are two types of harmonics. Space harmonic will be there, time harmonic will be there. Okay, so time harmonic will be different, space harmonic will be different. Now of course in books okay, they say that they'll consider space harmonic only and they say that time harmonic can be neglected. Even if you see very popular okay, what do you say, popular publication solutions, they did not explain anything further such a big great question. Okay, directly they have given the answer and that answer is also frankly wrong. Okay, so point here is very simple. Okay, for example, 7th time harmonic, okay, means as of now many guys might be confused what is time, what is space and all, we will see in detail course. Okay, but at this point of time you have to understand when to use which formula, that's it. Okay, so if you think of time harmonic, normally we know that, for example, 7th harmonic time harmonic will have 7 times fundamental frequency. Okay, so in the rotor, what will be there? In the rotor, resistance will be there because rotor analysis is nothing but induction motor analysis. Okay, so in the rotor, what will be there? In the rotor, resistance will be there, reactance will be there. Okay, resistance will behave independent of frequency if you neglect skin effect. Forget about it, time being reactance. For example, for 50Hz reactance offered is X. For 150Hz reactance offered will be 3X. Because frequency is increased. For 5th harmonic component, it will be 5x. For 7th harmonic component, it will be 7x. Okay, so because of that, what will happen? Reactance offered is going to be increased. So if you keep on time harmonic component, reactance offered is increased, so impedance offered is increased, so currents flowing of that particular harmonic component will be reduced. So because of that, in our textbooks they say time harmonic can be neglected. And they will consider space harmonic only. In space harmonic, frequency will be same. We will see in the detailed analysis. Now, basically, why time harmonic should be considered in induction motor? Okay. Now, forget about induction motor. Let us think of generators. All generators, DC generator, AC generator, whatever may be, induction generator and all. Normally, generator, in drawing all the characteristics of generator, one thing should be constant. What is that? Speed of prime mover. Okay, so for example, my prime mover and this is load, this is a generator and prime mover generator are connected. Okay, now in drawing generator OCC characteristics, SCC characteristics, load characteristics, blah blah blah, whatever it may be, in drawing all these characteristics, prime mover speed is considered as constant. But for example, if you want to consider speed regulation of prime mover, okay, for example, this is generator, this is prime mover, both are connected, both are rotating at no load. Now the moment my generator is loaded means that my prime mover is loaded. So from no load to load, prime mover speed, depending upon the speed regulation of the prime mover speed should be reduced or not? Yes. But still, in no other machine we consider speed regulation of prime mover. Okay, because prime mover is assumed to be having infinite mechanical inertia, or forget about all. In drawing all the characteristics of all generators, speed of prime mover is not, speed regulation of prime mover is not considered. Okay, means that for example, this is generator, this is prime mover, and these two are connected. Now, if load is increased on this particular generator, prime mover speed will be reduced. Now, for example, if you want to analyze this prime mover speed reduction, you have to remove generator, you have to analyze mechanical prime mover. Is it required for us? No. Okay, so normally we say in all generators, prime mover speed regulation should not be considered, is assumed to be constant. But only in one case we are going to consider speed regulation of prime mover. What is that? Alternator. Okay, why speed regulation? Load frequency control of your power system, drooping characteristics will be there. We are going to discuss in load frequency control of your power system. Okay, so point here is very simple. Okay, alternators and prime mover. In DC generator, for example, we don't consider speed regulation of prime mover, because means existence of DC generator is very rare. In that condition, speed regulation of prime mover need not be considered. Now, for example, induction generator. For induction generator, when load is increased, prime mover speed regulation. I am not bothered about the machine, but I am bothered about my electrical machine, but I am bothered about my prime mover. So, prime mover speed regulation will not be considered in induction generator, because induction generator existence in practice is very less, limited. But if you think of alternator, depending upon the weight, we are going to focus. Okay, so in alternator, all over India, thousands and thousands of alternators are there. So the moment weight is more, in the sense practical existence is more, we have to consider speed regulation of prime mover. So conclusion is very simple. In no other generator except alternator, speed regulation of prime mover will be considered. Okay, because that weight is more, practical existence is more. Now forget about it. Now let us think of induction motor. Okay, it means in all the motors, let us think of transformer from primary is a motor or not. Yes. So what is the source waveform of the transformer? We assume it as sinusoid, is the first and foremost assumption. For example, DC motor. Okay, in DC motor it is assumed, my supply voltage is assumed to be constant. For example, induction motor. Okay, for example, let me think of synchronous motor. In synchronous motor, power supply to the motor is assumed to be sinusoid. Okay, but in induction motor, we should not. Why? Because practical existence of input voltage of induction motor may not be sinusoid. For example, VV/VF control. Okay, or you may use voltage, because how to control speed of induction? Because induction motor is everywhere. Okay, so the moment induction motor is everywhere, most of the induction motors are controlled by power electronic equipments. Okay, so the weight, actually the practical existence of power electronic equipments are more along with the induction motor. So induction motor input voltage may not be sinusoid. Okay, in all motors we are not considering. Why we are considering induction motor? But practical existence is more. For example, input voltage of my induction motor can be like this, multi-level inverter or something. Okay, so if input voltage, see here, means only in induction motor we consider this. Okay, not in other motors, because of some reasons we will see later. Now for example, if I think of this is having fundamental, and maybe other harmonic components also will be there or not. If you give this particular stepped black wave to Fourier divided into fundamental sinusoid and maybe 5th order, 7th order, whatever it may be, those many harmonics. Now in normal machines we don't consider this particular steppedness, or we are going to consider only sinusoid, but in induction motor we are going to consider, because of two reasons. Okay, because in induction motor, fundamentally induction motor will interact with all the RMFs, because independent of relative velocity between stator MMF and rotor, torques will be produced. One thing. Okay, so with respect to fundamental also torque will be produced in the rotor. With respect to 5th harmonic component also, 7th harmonic component also, 11th harmonic component also, torques will be induced. Getting my point, right? Now next thing is most of the induction motors are controlled by power electronic equipment, so practical existence is more, so weight is more. Okay, now Come back to input voltage now. Let us read the question again. Okay, so square wave 6-step VSI voltage source inverter. Okay, voltage source inverter feeds 4-pole 3-phase 4-pole induction motor. The VSI line voltages has dominant fifth harmonic component. So in our previous basic concepts of rotating machine, what did I say? Always voltages and currents are time. Okay, voltages and currents are time only. Remaining MMF, flux density, flux can either be space or time. Okay, so anyway, point here is very simple. The question asked is time, not space, because voltage source inverter input voltage is having stepped voltage, so fifth harmonic component is dominating. Now in induction motor, if you can calculate slip, problem is solved, because everything is related to slip only, no? Okay. Okay, everything is related to slip only. Okay, so in induction motor, what is the only one and only independent variable? Slip. So if I can calculate slip, automatically my induction motor analysis is going to be completed. Okay, now if we see, means of course how it is happening I am not going to deal, but remember this way. For example, harmonics. Okay, so harmonics in torque, actually because of torque harmonics, okay, let me tell you that also. For example, okay, we'll see okay, let us deal. Okay, for example, this is the traction. Okay, railway track. Upon that my wheel is there. Now to this wheel, for example, induction motor is connected. Okay, then what will happen? For example, because of many torques, one torque is rotating in this direction, another torque is rotating in this direction, another torque is rotating in this direction. So because of, actually this particular wheel will continuously rotate at 40 kmph. For example, because of average torque is positive, but in that, some vibrations will be there, no? So because of that, my track wear and tear will be more or not? Yes. Okay, so point here is, because of these particular harmonic torques, what will happen? Wear and tear of bearings, means my life of bearings or life of moving parts will be reduced. Okay, so that's why it's a very popular proverb from electrical point of view. For example, if an induction motor, 3-phase induction motor, stop rotating, first thing you have to do is go and check bearings. That's it, because it is most rugged except bearings. Okay, because of these torques and all. Anyway, harmonics H order harmonic component. Okay, we know that even harmonic component will not exist. So for example, 2 n plus or minus 1. N is an integer. So the moment n is an integer, 2 into something plus or minus 1 is going to be odd only. Odd harmonics only has to be considered. And in 3-phase system, triplet harmonic component cannot be there. Even if you don't know, forget about it, we'll see in detail, because ultimately triplet harmonic component has to be analyzed only in transformer. Except triplet harmonic, remaining all harmonics has to be analyzed in rotating machine. So it is going to be 3. Okay, now if you see, just wait, 6n plus or minus 1. Now if you observe, if n equal to 1, 6 plus 1 is going to be 7, 6 minus 1 is going to be 5. So 5, 7, and 6 equal to 2, 6 into 2, 12 minus 1, 11, 12 plus 1, 13. So in this harmonic component, are you getting even? No. Are you getting triplet, third harmonic component? No. So these harmonic components has to be analyzed in rotating machine. So this is going to be the equation for a generalized harmonic component. Okay, now next point here is space harmonic can be there, time harmonic can be there. Okay, so in this harmonic component, just remember this dear, because if question come, okay, means 90% or more than 90% of faculties does not know about harmonics. Okay, so point here is harmonics, let me divide it into space, time. When time harmonics has to be analyzed, if in the basically in the textbooks they can say time harmonics are negligible, let us consider only space. But though it is negligible, question can come in exam, because they have given this is voltage question only. Okay, voltage source inverter, voltage, it's a input side, so it should be time harmonic. Now in time harmonic, in time harmonic or space harmonic. Let us see what is synchronous speed is going to be 120 f by p. Okay, so in space harmonic, just remember as it is, we will see later. In space harmonic, number of poles of H harmonic component will be H times fundamental. So ns of H harmonic is going to be 120 f by H times p. Or we can say that ns1 fundamental divided by H means that fifth harmonic component will rotate at 1 by 5 times fundamental. Now let us think of time. If you think of time, ns of H harmonic component is going to be H harmonic component in time, fifth harmonic component will be, frequency will be 5 times. Poles will be same, just remember as it is. Okay, frequency will be seventh harmonic component 7 times it will be, but number of poles will be same. We will discuss this about the in detail course. So this is going to be 120 into HF divided by P. So this is going to be H times ns1 fundamental. Now only one small thing has to be analyzed, that is like in this equation if you use plus, means that 7th harmonic, 13th harmonic and these particular direction of RMF for phase sequence, for example fundamental phase sequence is ABC, if you use plus, phase sequence is going to be ABC only. And if you use minus, actually though you are confused, don't bother, at the end you will remember everything. Okay, or again that is the main advantage of online. Now just rewatch the video. Now if you use minus, in the sense 5th harmonic, 11th harmonic phase sequence is going to be ACB, means that if fundamental RMF is rotating in anti-clockwise direction, fundamental RMF is rotating in anti-clockwise direction, my 7th harmonic and 13th harmonic also will rotate in anti-clockwise direction only, but 5th and 11th ACB phase sequence RMF will be rotated in opposite direction. Problem solved. Okay, now let us try to understand. Okay, means my time and space. For example, in this question, what they have given, like 4 pole 50 H. 4 pole 50 H. I am going to discuss how to calculate slip for time also, how to calculate slip for space also. Okay, 4 pole 50 H machine. Okay, in this, what is the synchronous speed of fundamental? Synchronous speed of fundamental 4 pole is going to be 1500 RPM. Okay, now what is rotor speed? Rotor speed is going to be 4% is the slip, right? Yes, 4% is the slip. So 1.04, 1 minus S into 1500 is going to be 1 minus 0.04 into 1500 is going to be 1440 RPM. Now just observe the difference, for example, if you think of fundamental MMF created by the stator is rotating in one direction, and maybe 5th harmonic component may rotate in opposite direction, 7th harmonic component may rotate in the same direction. Now that speed of the the RMF speed will be decided by whether it is time or space. Okay, now point here is, but if you think of rotor, okay, so virtual poles can rotate in any directions because those poles are virtual created by stator. But rotor has to be rotated in only one speed. Some part of the rotor cannot rotate at another speed and some part of the rotor cannot be rotated at another speed because it is physical object. Okay, so rotor speed will not be changed. Okay, now let us calculate. For example, they asked time, right? Because voltage and currents should be time. Okay, they asked 5th harmonic. They asked 5th harmonic. So 5th harmonic component. So ns of 5th harmonic is going to be 5 times time 5 times. So 5 into 1500 RPM. 5th harmonic component. Okay. Now what is rotor speed is going to be 1440 only. Now if rotor is rotating in one direction, okay, always rotor will rotate in the same direction of RMF created by stator fundamental. Now 5th harmonic component will rotate in opposite direction because ACB is the phase sequence. Okay, so point here is very simple. If rotor is rotating in this direction, or forget about rotor, fundamental is rotating in this direction, 5th harmonic rotates in opposite direction. Now rotor is rotating in fundamental direction. So what is the relative speed actually? Actually they may give you different formulas and all. Formulas are not at all required. Okay, if you see my class notes, you might got formulas Don't remember that. Just to scare people, like, sometimes we have to do that as faculties, okay? Now, if rotor is rotating in this direction with 1440, my stator MMF is rotating in this direction with 5 into 1500. So, what is the relative velocity? What is the relative velocity is the addition. So, what is the slip actually? Slip for fifth harmonic equal to ns of fifth harmonic, or okay, let me write slip first, ns minus nr by ns. Okay, so slip for fifth harmonic component is going to be fifth harmonic, relative velocity is plus because opposite direction. Problem solved. So this is going to be 5 into 1500 plus 1440 nr into divided by 5 into 1500. Okay, and I will do space time also, space also, just wait. So 5 into 1500 plus 1440 divided by 5 into 1500, 1.192. Okay, for example, in space only, if they ask you seventh harmonic, okay, let us see if they ask you in space only seventh harmonic component, how to analyze. Okay, for example, sorry, time only. So for example, time only, they ask you seventh harmonic slip, for example, for the same question. Okay, so how much will be seventh harmonic? This what is synchronous speed? 7 into 1500 because it is time. Okay, now what is S7 is going to be? Rotor, my seventh harmonic component will be aligned with the phase sequence of the fundamental. Okay, so fundamental is rotating in this direction, so seventh harmonic also will rotate in the same direction because we have to use plus in the generic equation of h equal to 6n plus or minus 1, 6n plus 1 is going to be 7. So RMF is rotating in this direction, rotor also is rotating in the same direction, so relative velocity should be ns minus nr. So this is going to be ns minus nr by ns. Seventh harmonic. Rotor speed as it is a physical object, it will be same. So this is going to be ns7 into 1500 minus 1440 by 7 into 1500 will be the answer. Now let us think of space. Space in the sense directly they will ask you. Okay, so if they don't give you anything, it will be space. If they give you inverter, 6-step, input voltage, so in that conditions time should be taken. Normal conditions directly we can take space. For example, they might ask you fifth harmonic space only. Okay, so what is fundamental is going to be 1500 rpm. So what is fifth harmonic component is going to be 1500 by 5 because it is space. Now let us calculate slip of fifth harmonic component is going to be ns minus nr by ns. Of fifth harmonic, nr will be same speed and opposite rotation because you have to use minus in the equation of h equal to 6n minus 1 is going to be 5. Okay, so ns5 is 1500 by 5 plus nr is going to be 1440 by 1500 by 5. Okay, next thing is, for example, if they ask you space, what do you say, seventh. Okay, space 7. Okay, now what is fundamental? ns1 equal to 1500 rpm and ns7 equal to 1500 by 7 because it is space. Okay, so how this is happening we will see in detail course because we don't have that much time now. Okay, means with this you will be able to get solve the question in the exam, that is enough. Okay, now what is slip here is going to be ns minus nr by ns. Seventh harmonic, speed of rotor is going to be same and it should be minus only because seventh harmonic is going to be 6n plus 1. Phase sequence will be same. So this is going to be 1500 by 7 minus nr is going to be 1440 divided by 1500 by 7. Problem solved. Okay, so conclusion is very simple. Why we are calculating slip with the fifth harmonic, seventh harmonic and all? Why not in synchronous machine? Because synchronous machine, go back and check the videos. In synchronous machine, when the relative velocity between stator MMF and rotor is 0, then only steady torque will be produced. Okay, but here in induction machine, independent of relative velocity between stator mmf and rotor, if you see our points to remember in our telegram channel, automatically in the points to remember I have written clearly. Okay, so independent of relative velocity between stator mmf and rotor, torque will be produced in only induction. So my induction machine rotor will interact with 7th harmonic also, interact with 5th harmonic also, interact with 13th harmonic also. So because of all these, torque will be produced in the rotor. So my torque in actual machine, torque produced in our induction motor rotor is going to be because of net average of all these torques. Okay, anyway, this is the way problem has to be solved. It's damn good question.